Hi guys, in our DP series, today we'll be attempting the painting pencil algorithm. This is a pretty popular question and I myself have recently encountered this question in a GB Morgan paper. So firstly, let's start with the problem description. After that, we'll dive deep into the approaches that we can take. Okay, so the question goes like this. Given a fence with n posts and k colors, find out the number of ways of painting the fence such that at most two adjacent posts have the same color. This is the most important condition. Since answer can be large, return it with a module of 10 to the power 9 plus 7. Got it. So firstly, let's try to understand what it's asking us. Take an example. That's the best way to understand the problem. So let's take the small example. N equals to 3 and k equals to 2, where n is the number of posts and k is the number of colors, right? So let's try to imagine we have three posts, three sort of fences, and we have two colors to paint them with. Now, how many orders can we come up with such that no two adjacent posts have the same color? Okay, since we only have three posts, there can be only two failure cases. Let me just, for a second divide them into two cases: failure cases, success cases. So since we have a small n, we have only three posts, there can only be two failure cases, and those two failure cases will be uh, they both all the three posts are in one color. Okay, let's say if we have two colors A and B, so all the three posts are in A color or B color. Only those can be the two failure cases. Okay, basically how many total cases we can have? Since we have three posts and we have two color, we can in total have eight cases. If I simply subtract the failure cases, that is two, we get six as an answer. But let's try to actually find out the success patterns. So let's just try to draw them out here. What can be the success pattern? We have n as 3 and k as 2. Okay, let's assume we have two colors A and B, right? Okay, so one pattern can be A, the other can be A, and the other can be B, right? What can be the other pattern? mm, B, ABB. Is there anything else? mm, Only we have triple A and triple B, but that is wrong. So yeah, basically these are the six cases that we can have. Okay, AAB, ABA, BA, BBA, BAB, and BAB, right? So basically for this question, our answer will be 6. When n is 3, k equals 2, our answer will be 6. Okay, but apparently we can't take this approach, the one we took just now. Reason being, right now our n is the smallest, but n can be very large, right? So our failure cases will be more as compared to our success cases, right? So that is not the approach that we might take. So let me just trigger a memory. I believe you have solved this type of question not when you were doing coding, but when you were doing quants, specifically in the permutation and combination section. I hope you remember you have approached a few questions that goes like this: that you have five boys and five girls, and you have to find the total number of combinations such that no two boys are together or no two girls are together. So using the rest of that question, we'll be attempting this one. Okay. So now let's go take an example, analyze this question, and come up with an approach. Okay. So to simplify this question, let's only consider right now two poles. Okay. When you have two poles, what can be the cases? Okay. Let's forget success cases. Let's just talk about the cases. What can be the cases? So one case can be that they have the same color, right? What can be the other case? The other case can be that they have the different color, right? Okay, great. Now let's actually also have an example and we'll solve it. Okay, so for the example, what should we take? Let's say n equals to 4. Okay, which means the number of poles that we have is 4, and k equals to 3, which means the number of color that we have is 3. The colors are, let's say, ABC. Fine. Okay, let me also draw a table, and then what we'll do is we'll try to manually solve this question till we reach the third pole, and for the fourth pole we'll try to automate it. We'll try to somehow find a pattern and then solve it. Okay, let me just draw a table real quick. Okay, I wrote the cases with respect to only two poles, but via those two poles will traverse all the n poles. Let me show you how. Okay, so firstly, when we have one pole, if you have one pole, then what are the total number of ways that you can paint that pole, that fence? So the answer will be the total number of colors you have, right? If you have three colors, you can paint that particular fence in three, with three color three, by three ways. Okay, so the answer will be, right now the k is three, so we'll say three. Okay, great. Now let's talk when we have two poles. Okay, if you have two poles, then what are the ways in which you can have the same color? So the ways will be A, B, B, and C. So the total ways will be three. Correct? Okay. What about when I say that you have to, both the poles should have different color? So let's go A, B, B, C. Okay, actually A, B, A, C. That is more better. B, A, B, C, and C, A, C, B. Correct? So totally we have six ways, right? Great. Now, let me also write the answer. The total number of ways will be nine. Correct? We are actually respecting the condition that we were given, that at most two adjacent fences should have the same color. All right. Since we were only talking about the two poles, let's only consider the last two poles. Okay. You can also take the first two poles. That won't matter. But I'll just take the last two poles. Okay. That's more easy. So let same means the last two poles should have the same color. Okay, what can be the various condition? So you can actually try to find it out, or what you can do is you can just you can just copy out the AB AC BA BC CA CB, and you can replicate the last character, the last color that they had. Okay, let me show you how. So these were the colors that we had in the different variation in the previous number of poles section, right? So I'll just replicate the last pole. Now that will I think that will be enough to satisfy a condition. Our condition was that the last two poles should have the same color, right? So ABB, ACC, BAA, BCC, CAA, and CBB. Okay. The total number of ways here we have six. Okay. Even now we are respecting the condition of the question that we were given, that at most two poles should have the same color. Okay. Right. Now what about this part? Now it's a little bit tricky. Let's say. So we are supposed to find diff. Diff by diff means that the last two poles should have different color. Okay, I say tricky, but actually it's not tricky. What are you supposed to do? You are supposed to, you in the in the previous part. When I say previous part, I mean when you have two poles. When you had two poles, you had nine such combinations that were correct for you, right? So let's actually try to find out, since they were the nine correct variations, we'll actually try to modify them, and then we'll actually try to only add one pole in those variations, and that will be enough. When we add one pole in them, those two poles become three poles, right? And we can have a correct variation for us, because you had two poles with correct variation. When you add third pole provided with a correct condition, you will have a correct variation. Okay, so here you have, let me actually just write it, give me a second. So these were the conditions, right? A B B B C A B A C B A B C C A C C, right? Now I said, by adding one pole to the previous variation with the correct condition, you will have the correct variation for this order. Okay, what I mean by that is, you have A B B B C. The condition that we are right now working on is diff, which means that the last two poles should have different color. Okay, A B B B C B A. Okay, so how you can do that? Very simple. Just choose, just take the pole that you have, and just take the combination you have, and make the last pole of any other color than it previously had. Okay, what I mean by that is, you have A right now. Okay, let's just talk about A right now. Just give me a second. Let's talk about A. So AA had two poles, right? AA had two poles. Right now I want to create something for, I want to create a variation for three poles. Okay, so AA can become AAB and AAC. That is correct, right? It satisfies my condition for diff. It also satisfies the condition of the question. Okay, AA will become AB AAC. BB can become BBA BBC. BC will become BCA BCB. Right? So every previous, I'll just write okay here. So every previous combination that you had, let me just show you. here all the previous combination that you had total 9 combination, right? In those 9 combination, if you add any color other than the color that the last pole had, you will create a correct variation, right? So how many total number of uh, how many total number of variation you can have for this particular section? I can actually write it down, but I won't write it down because I'm trying to create a pattern. So the pattern will be the total number of poles that you had in the previous section with 2 poles multiplied by colors other than what the last pole had. So last pole can only have one color, right? So the what will be the colors other than, it will be k minus 2, sorry, k minus 1. So for this case it will be 9 minus 2, that will be 18, right? Correct. So you have 18 for diff and for same you have 6. Okay, so the total answer will be 18 plus 6, that will be 24. Correct. Now as I said, for the fourth pole we'll try to automate the process. So as you can see, the for for when you had 3 4, how did I find the number of same when I was saying for the same color, I used the diff of the previous one, right? I just added the same color, and that way I had the one I had, sorry, I created the same for the next section. Okay, so that you can see that it is going like this. Okay, what about the diff of the previous one? For that, you just need to have the total of previous section and you need to multiply it by what? K minus 1. Okay, that way you'll get, so 9 into 2 will be 18, right? Now let's try to just do that. So what about 14? What about the same section? So this 18 will go there. Now how, if you want to just if you want to talk about, we can talk about it. So AAB AAC. Okay, what you are supposed to do, AAB will become AABB when it goes here. AAC will become AACC, right? We are still following that condition that at most, what was the condition that sorry, at most two adjacent posts are the same color, right? We are still having at most two. We have AABB. What will be incorrect if we had AAAB, right? Correct. Now what about this? What about the diff? So 24 is supposed to go there, but it should be multiplied by k minus 1. That will be 24 into 2. That will be 48, right? So you add it and you get 66, right? I hope it's pretty clear with you. I only took 2 poles. I considered them to be last pole. That way, they can only be 2 correct cases, that they are same, they are different. I considered them. I created the variations. Why am I why am I so sure that the variation the sorry, the pattern that I wrote for 3 are correct? Because I created the pattern for 3 from the pattern of 2, and and as you can see that we wrote the pattern of 2, we are sure that the pattern of 2 were correct. Okay, so that way the pattern of 3 are ultimately correct, and that way you can just keep going on and on, right? So I hope it's pretty clear. You can actually just see the by now you already must have a picture of the code in the mind, but let's just try to code it out also. This is you can say that this is a DB problem. Okay, let me just try to practice this. Let's change the language. Got it. Right. So let's start with the condition. Firstly, if n equals to 1, but if there was only one pole, then the answer will be the number of colors that you have, right? What if you have 2 poles? Then the answer will be, what will be the answer? Let's see here, 3 9, or you can also say it k square, right? uh, let's use the concept of same and diff. The value of same initially would be 0. The value of diff initially would be not k, I'm so sorry, will be k, right? And the total, which means the total answer will be 0 initially. Okay, let's try to now traverse the whole sorry, let's try to actually traverse the whole poles, 1 to n plus 1. Okay, the same analogy. Total will be basically what it will be, the summation of same plus diff, correct? Sorry, and one thing more, you have to take a mod with that, right? Now we'll actually upgrade the values. So same will become diff, right? And diff will become what? It will become total into k minus 1. Since value can exceed again 10 to the power 9 plus 7 here, we'll again take a mod here. Okay, and at the end, let's just try to return the total. Okay, let's try to compile and run it here. Mod is not defined. Okay, okay, and we're done here. Yeah, 6 correct. Let's try to submit that again. Okay, so this is our space optimized approach. Here we have literally just wrote the process, the thought we analyze here, and then we just simply wrote that. All right, so this was a solution for painting fence. If you have any questions, feel free to ask them in the comment section. Thank you so much.